Myself, Professor D.S. Rai, Professor, Department of Civil Engineering, BBD, IITM, Lucknow. Today, we are going to cover course KCE 076 Urban Transportation Planning. Today lecture is lecture number 23, in which we will discuss model split part 2. First, we have already covered. References that I have taken Chakrabarti, Partho and Das Animes, Principle of Transportation Engineering, Papacosta CS and Prevenderus PD, Transportation Engineering and Planning, Kadialia and Lal, Principle and Practices of Highway Engineering, and BTL, and some material have been taken from internet. The contents today we will cover component of utility function, deterministic and systematic portion of utility, utility associated with attributes of alternatives, utility bias due to excluded variables, utility related to characteristic of decision makers, basic construct of utility theory, properties of utility function, prediction of aggregate travel behavior, inadequacy of deterministic utility models, omission of relevant variables from models, measurement errors, proxy variables, etc. So, now come to the component of utility function. Deterministic or observable portion of utility function can be broken into three components. First, exclusively related to the attributes of alternatives. Second, exclusively related to characteristic of decision makers. Third, represents interaction between the attribute of alternatives and the characteristic of the decision makers. Deterministic or systematic portion of utility. Deterministic and systematic portion of utility can be represented by V t dash I is equal to V into S t plus V into x I plus V into S t into x I. V x I is associated with the attribute of alternative I. V S t x I represents interaction between the attributes of alternatives I and the characteristic of individual t. V t dash I is equal to V S t plus V x I plus V S t into x I, where V t into I is a systematic portion of utility of alternative I for individuals t. V x I is associated with attributes of alternative I. V S t x I represents interaction between the attributes of alternative I and the characteristic of individual t. Utility associated with the attributes of alternatives. This part includes variables that describe the attributes of alternatives. Attributes included in this components are service attributes, which are measurable and are expected to influence people's preference choice among the alternatives, and that are travel time, travel cost, how much travel time, how much time will be used from one origin to one destination. Travel cost, how much cost will involve from origin to destination. Number of transfer, how many points where the transfer could be done, and comfort. It is very important in context of today. Reliability, whether it is reliable or not, whether it will reach the destination at proper time, proper routes or not. So, these are the factors, choices or preferences. Utility bias due to excluded variables. Inclusion of all factors that influence alternatives in the utility function is not possible, since many of them are difficult to measure and predict. To solve this, appropriate constant terms are added to the utility function of all modes except one, base mode, which are called alternative specific constants. Alternative specific constant of a mode is the average amount of factors not included in utility function contribute to the difference between the utility of the given mode and base mode. Utility related to characteristic of decision maker. Utility related to characteristic of decision makers. The differences is biased across individual can be represented by incorporating personal and household variables in mode of choice models. These variables includes various travelers characteristics, and that characteristic include household income, how much income of this family, age and gender, what is the age of individuals, what is the gender of individuals. Why it is important? Because younger will go to school, or their requirement is slightly different from others. Senior citizen will go for their own purpose, for walking and just like that. Genders are also important. Female generally want to travel in daytime where the rush is less, so that they can purchase vegetables etc. for the household. Man wants to go or go for trip in daytime along with the family. Vehicle ownership of the household, it is also important. Number of workers in a household, how many persons are working in a household, it is also important. Utility by interaction between the attribute of alternatives and decision makers. This component consider differences in how attributes are evaluated by the different decision makers. One effect of income is to increase the preference for travel by the private automobile. This means increasing income reduces importance of monetary cost in the evaluation of modal alternatives. Another interaction effect might be that a different travelers, that is men or women, evaluate travel time differently, because when the men are away from the house for work, women are free in the midday. So, they want to travel in midday for purchasing of a different thing for the household, where men want to go for a trip in evening along with whole family. Basic construct of utility theory. Operational model for predicting individuals' choices are based on the behavioral principle called utility maximization. According to the utility maximization principle, the utility function U depends on the attribute of available option and the individuals, and individual chooses the most preferred option, which maximizes the utility function value. The basic construct of utility theory accordingly, given a choice among many options, alternative I in C is chosen if U I in bracket x into s is more than U j in bracket x into s for all parameters of j other than I in C, where C is a choice set. X attribute of alternatives, S is attributes of individuals. Now, property of utility function. Function U is the same for all options. Differences among options are accounted for by differences in the numerical value of attribute x. Utility of an alternative depends only on attributes of the alternatives and the individuals. Utility function contains no information regarding the strength of the preference. Prediction of aggregate travel behavior. Utility maximization principle and utility based choice model are used for describing and predicting choices made by individuals. However, practical travel demand analysis is concerned with the aggregate outcome or demand. The aggregate travel behavior can be obtained from utility models by simply adding model prediction of the choices of a different individual. Aggregate behavior cannot be predicted correctly by averaging the utility value of each mode over individuals. The average utility of drive alone, carpool and bus This example is minus 1.54 into, that is 0.2 into minus 2.3 plus 0.35 into minus 1.63 plus and so on, 0.1 into minus 0.95, minus 1.27 and minus 1.31 respectively. The use of average utility value results in enormous prediction that all travelers in population prefer to carpool. Inadequacy of deterministic utility models. The theory of travel choice yields simplified models of deterministic prediction of travel choices called deterministic utility models. As per these models, similar individuals are expected to make same travel choice when face the same set of alternatives. In practice, even some individual may make a different choice when faced with the same alternative on a different occasion. These models do not consider such unexplained variation in the travel behavior, thus provides inadequate description of travel behavior, source of inadequacy. Analysts and the individuals making the travel choices being modeled are unlikely to have same information about the availability of alternatives. Analyst is unlikely to know all the characteristics of each individual that are relevant to mode choice. Limitation of analysis. Limitation of analysis information. 5 specific limitations of analysis knowledge are: first, omission of relevant variables from models. Second, measurement error. Third, use of proxy variables. Next, differences between the individuals may be ignored. Next, day to day variation in the choice context may be ignored. So, these are the limitations, but these things happens and should be considered while predicting the trips in the future. Now, come to the omission of relevant variables from models. Omission of relevant variables from the models. A model of mode choice may omit one or more variables that are important to the travelers. Omission may achieve a useful signification of the model, or maybe analytics does not have data on the omitted variables. For instance, apart from travel time and travel cost, mode choice may vary if traveler consider other factors such as comfort and reliability. This comfort and reliability is a very important for all travelers. If a person has no money, then he will not consider comfort, he will have to go to the destination only. But as the group of income increases, the comfort will come in existence and people will try to travel or make a trip in a comfort zone. Reliability, whether this train will reach to the destination in the proper time or not. So, this is the reliability. Measurement of errors, analysis, information about the service quality may be subject to measurement errors. For example, data on travel time may be obtained from network models that yield estimate of travel times between zone centroids. These estimates may be enormous due to network coding error. Errors in the assumed volume delay function or because the trip in question originate or terminate at location other than the zone centroid. So, proxy variables, it is often necessary in practical modeling to use variables that are different from ones that are theoretically appropriate. For example, income is often used as a proxy variable for automobile ownership in mode choice model. Sometimes the trip makers, due to importance of the work, changes their modes. If they have to reach the workplace at a time when there is a very important works are going on, then he will leave transit and use car, or if not available then taxi. So, that depend upon how he is using the mode choice. So, suppose every day he is using a bus for a particular place or a trip. But suppose on Sunday, if he wants to go or make a trip with the family, then he will slightly bear more money to make the trip comfortable. So, here the choice of mode is changed, depends upon the actuality of the problems. So, now differences between the individuals may be ignored. Different individuals may evaluate alternatives differently. For example, differences in cost among the alternatives may be less important to wealthy people than to the poor people. Differences such as a physical characteristic of the individual that may affect the importance of seating availability, walk distance and or wait time may not be known to any analyst. If analysts do not know that individuals belongs to different preference group it will appear that identical individuals, same income and a car ownership make a different choice when faced with the identical alternatives. Day to day variation to the choice context may be ignored. The data used in mode choice modeling do not include information to day variation in the choice context that may affect mode choice. For example, a short term availability of a car due to repair needs or variation in the need of another family. Members need to carry heavy package on the particular day, etc. So, that is the end of this mode split choice. Thank you very much.